This meeting is being recorded.
In problem 21 from chapter 7, we are asked to draw the carbocation intermediate that would be expected when any of these alkyl halides undergoes ionization. So we know that in both SN1 and E1 processes, we can generate this carbocation intermediate. And we're also reminded, in addition to just drawing the carbocation, if it is resonance stabilized, we're asked to draw those resonance structures as well. So for compound A here, we would see that this bromide would serve as our leaving group, and the remaining compound left behind would be this carbocation. So we would draw here as our cationic site after we lose that bromide leaving group. In compound B, we see something similar. So we would lose at this site here and generate this as our carbocation intermediate. And you may notice that none of these structures will have resonance. So we'll see with the second half of this question that we have some resonance structures generated. But once again, here we have this carbocation intermediate generated. And then with structure D here, we will also have a carbocation intermediate generated. And it will look something like this here. And we'll remove this marking here. So these are all of the carbocation intermediates that will be generated without having resonance structures. So let's take a look at the second half of this question here for parts E through H. And we can see that a resonance structure will be generated if we deprotonate, or if we have this leaving group here, and we generate our carbocationic site right here. You can see that this is in an allylic position. So we could move this pi bond electrons over here and generate this resonance structure shown. So that's for E. With compound F, we see something similar. So this is our leaving group here. So initially, we would generate this carbocation shown here, which is in a benzylic position. So we have resonance stabilization of that positive charge, which could involve all three of those pi bonds in the benzene ring. So we can see all 5 of these resonance structures generated down here for compound F. For G, we only will have one site for our carbocation, so it will look like this, no resonance structures generated. But what we see with compound H here is after that chloride leaves, we would generate this initial carbocation, and it is what we could call doubly allylic. So we would have a total of 3 resonance structures generated as our carbocation for compound H.